This tutorial starts with a song, but it's only a few seconds long.
Computer animation. Computer animation. Computer animation.
Let's get started with animation. This is about character animation, and the tutorial consists of 3 parts. In the first part, we import a walking skeleton. Not something which you can render, because for rendering you need a skinning a skeleton. That's not important for this tutorial. I've done other tutorials about skinning, but importing a skeleton, and the skeleton walks, and it's a motion capture skeleton. And the second step will be this: we create an IK-driven leg, just a single leg. And in the third part, which is the most exciting part really of this tutorial, we'll try to mimic or copy the motions of the Mocap character, of the walking character, to our leg. We copy the motion of the left leg to our IK leg. And this is the starting point for lots and lots of challenging tasks to animate an IK skeleton. Really interesting and very handy. If you understand this tutorial, you can go anywhere with character animation. So let's get started, and before we start getting into character animation, we need to change the dimensions of this grid here, because when we import a character now, he or she is entering the scene extremely large, and the reason is that this is a centimeter unit. So we go to Windows, Settings and Preferences, and under Preferences we go to Settings. I think it's a little bit too complicated, but that's the way it is. And here you see we have working units in centimeters, and we want to have meters. Save. So you see the grid has changed. When you type the key A to see all, you see basically the same as before, but now this is 1 meter. And that makes quite a difference when you import a character now. And we're going to import the character now. We go to Windows again, and under the general editors, you find the content browser. The content browser is the place where you have all kinds of things which you can use for creating fire, for example, and characters. And under motion capture, this is this folder here, you have subfolders like generic male, female, and let's pick Carol in this case, walk straight. You can use another walk, but if you find Carol walking straight, choose this one, double click. So she lands in the scene. Where is she? She's right here. Let's change the background. That's Alt B. And as I said, no skin, just the skeleton. But the skeleton does what we want. It walks. Now, a brief analysis of this skeleton. When I pick the hip, which is the central joint in this skeleton, in most skeletons actually, you see lots and lots of keyframes. Most of them are obsolete, and they all control the motion of the hip. When you click here, you open the whole hierarchy. And for example, if you go to walking straight, whatever that is, it's the hand, the right hand, you see keyframes all over the place, although the hand probably moves just a little and you need maybe only 1/10 of the amount of keyframes here. But if you have a look at the attribute editor, you see the rotation attributes are animated only because they turn up in red. So it's nothing about translation, and that's a sign that, let's go to just another thing here, the chest, same here, the rotation channels. That's a sign for forward kinematics. Forward kinematics is rotation. You rotate each joint, and that's what's done here. So in order to change something here, for example, rotate this character so it bows down a little bit, set a keyframe here for this rotation, right mouse click set key, then you get a very odd motion. You see, this part, because you have to change the whole environment here in order to get things straight. And the whole environment doesn't mean the environment for this bone here, this joint, but for all the others, because all the others have keyframes too, and it, of course, rotating one of them affects all the rest, and you have to readjust them. So it's not a very flexible way to animate your own character, and that's what this tutorial is about, basically. So let's undo this. This concludes the first part of the tutorial. For the second part, we'll do this. We'll concentrate on left leg, and so we're not interested in the right leg. What we'll do now is we'll hide the right leg, H. Now what we'll do next is we select the root here, which is, or we can select that one, and we want to template it. A template is something which makes the joints not invisible but not pickable, because we don't want to pick them, we just want to see them as a reference. And that's what we're going to do now by going to display, because that's a display thing. And then we need to go to objects, because that's about our object, and here you find template. If you want to undo that or get it untemplated, you use this command. You pick it again in the outliner, and then you untemplate it. But we template it, doesn't change anything. Well, it does. When you deselect it, it is grayed out. So it still does the same job as before, but it's grayed out now. So now we close this whole section. You see it's yellow. That means it's a template. And we go to one of the side windows. We go to the side windows window which shows us the character from the side. Let's check this one. Is it the side X? Yes, it is. So we go to the very beginning of the animation, which is here. And we copy the leg now. Let us copy the leg when it is placed down like this in a pretty neutral way. Here is the hip. Here is the knee, the ankle, and the foot. And in a previous tutorial I showed you how to create such a skeleton with IK Kinematics. That's why I can accelerate things now. And I go to skeleton, which is rigging basically, and then skeleton and create joints. And I place the first one right here, second one at the knee, third one here, fourth and fifth, and I press enter, and then I've created a skeleton here. And when I go to the perspective view, I see the skeleton arrives somewhere in the middle, and of course I want to have it more or less on this side. When you have a skeleton which is not rectangular to one of the axes, you can rotate it by using this manipulator in order to get things started. But then you can continue working in 3D, of course, but we'll work in 2D, which shows you the whole process. All right. So we need IK handles now. As I said, consult the previous tutorial about how to create them. I create single chain solvers here, and I set the first one right here, the second one here. And now I select those two here for the foot and middle mouse drag them over the IK handle 1. That makes the whole thing a group. The hip of our skeleton is quite a complex thing. It is tilted right now because this is typical for a walk. We need to see exactly where our leg starts, this basically this point here. And when we look at the side view, we don't exactly know what it is. Is it here or there, or where is it? This is how I go about it. I create a sphere which lands in the scene. It's very big, and let me go here, and now I want to point constrain the sphere to this joint, so I see it in the side view better. You need to select that joint, and the best way to do this, I guess, is right here. When you locate it down here, it's the left leg right here. You select the left leg and with a shift key the sphere, and then you go to animation and you have constrain here and you point constrain that sphere to the leg. So when the leg moves, the sphere is always moving with it. And actually you can make it a little bit smaller. You need to deselect the leg so you can scale only the sphere. And I think I have an existing material which we can use here. It's a Lambert 2, so it looks like yellow. This is just a helping thing which makes the view in the side window much better. You see, this is the place where we should focus on. And now comes the fun part. We have basically 4 nodes we should deal with. One is the left leg top. It's basically the start of the hierarchy of the skeleton. This IK handle is spanning from that left leg top to the ankle, and let's call it IK1. This handle here, the 3, is the IK tip of the foot basically, and this is the IK for rolling the foot. So we're at the beginning of the animation, and what we'll do now is we'll select the left leg top. It's that one. It moves the whole leg, and this is what we want. We want to start high up in the hierarchy. Later on we'll deal with the IK1, which is our main IK handle, then with a rolling one, which is pointing to the middle of the foot, and then finally with the tip. That's the hierarchy you would typically do it. If you start in another sequence, you'll run into deep problems, and you have to try it out to see for yourself. We'll move the locator right here. I press F in order to get a little bit closer, and we position it precisely there. And now we set a keyframe, and we set a keyframe not for the rotation, because in Inverse Kinematics it's all about translation. So we press the Shift key, press and hold the Shift key, and W. That places keyframes at frame 0 at the beginning of the animation, only for the translation channels. And that's very handy indeed, because we don't need all these things in red here, because we're only dealing with the translation. Actually, we're only translating the leg in 2 dimensions, but that doesn't matter. We see 3 keyframes here. So the keyframe sits down at the very bottom. And now the next thing we're going to do is we just try to follow that original skeleton. So let's go, for example, to frame 5. And we move it over here, slightly up. The closer you get, the more precise you can place it, like here. And now we need to press W again, I mean Shift W, to set keyframes right here at frame 5. And in the next step, we'll automize this a little bit, just a little bit, by auto key, which is down here. Let's switch it on. And but now we have to press Shift W again. Next time we don't have to place the keyframes manually like this. So let's go to frame 10 and move the leg over here. Now you see, because we have this icon checked on, it's in red now, we have auto key. So Maya remembers what you placed as keyframes last time, that was the translation in X, Y, Z, and writes the changes automatically into a keyframe. So this is the animation you have now. If you look at the bottom of the leg, it looks horrible. But we'll deal with this later. So let's go to frame 15. And I speed this up just a little bit so you don't get bored. And you have to try it out yourself anyway. We can do it in steps of 10 to start with. And don't be irritated about the rest of the leg. We'll fix this in the next step. So this is the hip animation, or the top of the leg, which is not really satisfying all our needs. That's why we go back to frame 0, and now we deal with this group IK1. That's our major handle. And you'll see that when I move this down here, that's where it belongs, the leg will become more or less intact. And I try to place it as precisely as possible. And I don't want to deal with the top one now. I just deal with that one. So I'm finished with the main IK handle now. So the animation looks like this now. Much better. Now I deal with the rolling part. That's the first part of the foot. Let's have a look now. Much better, because you see that the rolling part of the foot is planted while the foot is on the ground. This is okay, it's not floating anymore. And now we deal with the tip, which is the lowest node in our character animation here. It's amazing how dramatically the leg and the foot move, and sometimes they don't move at all because the foot is planted. And this looks quite nice. We can reduce this playback range here and loop the animation. You see a few problems which are not really problems, like here, for example. You see that our leg, which is the brown one in this case, is faster than the other one. So you can set keyframes here in between. And when you do that, work from the top of the hierarchy down. And now we're finished. This concludes part 3. And you can imagine when you have a character which or who walks up the stairs or goes around a corner, you can copy the whole animation, and then you have a very lean and easy to animate skeleton, and you're not limited by the extremely complex rotational forward kinematics of a motion capture character. And having said this, I wish you a very good day. Bye bye.